Greetings viewers, in this video we'll attempt Cambridge A-Level Further Mathematics, syllabus code 9231. This is paper 3 which is Further Mechanics component. This is variant 1 from the May June 2025 series. We'll go attempt question 2 now. The previous question is uploaded into the same playlist. Question 2 is about a projectile motion. So you can try attempt to sketch this out first. A particle P is projected with speed 24 meters per second at an angle theta above the horizontal from a point O. So let's say this O and everything else is a horizontal plane and it moves freely under gravity. And the horizontal distance at a horizontal distance of 35 meters, there is a vertical wall. So at Sx of 35 meters, there is a wall. Let's say this is the ground. There's a wall of 10 meters. So Sy is 10 meters. And we want to determine the value of this theta for which this projectile motion, it just clears it. So we want to find basically the particle, what value of theta it will meet at this point. Label our axis, right? This is y and x. And okay, we have these two information to work with. We also have gravity, or the acceleration in the y direction is negative 10 meters per second squared. So I don't know why this syllabus is still using 10 meters per second, but we will use that value lah. And it's going downward, so you will take the negative value because we already assigned upward as positive. Okay, and right, what else? Okay, ax acceleration in the horizontal direction, you take it as 0 because we assume that there's no what we call air resistance, right? We assume this is an assumption that we make so that to simplify our calculation. And yeah, so we're just going to make use of our kinematic equation here. In this case, we're probably going to use this one because we have we have our initial speed. U is 24 meters per second. So we can separate this into the horizontal, the x component, ux, and also the vertical component, uy. To do that, I hope you can recall it's just trigonometry, right? Ux, it will be u cosine theta, and uy, it will be u sine theta. So in the x direction, let's form the equation first because we have one variable we can eliminate straight away, which is the acceleration is 0. So Sx, it will be uxt plus ax, or half axt squared. So because again the acceleration is 0, this one goes to 0, and it will just be u cosine theta multiplied by t. And we can simplify this after substituting the values, and we will isolate t. We'll isolate t so that we can use this to eliminate in the other equation. So it'll be 35 over 24, and 1 over cosine theta, we'll write that as secant theta. Okay, so far this is this is the first equation that we have. Now we'll go for the y direction. So this is in the x direction. In the y direction, we're going to have Sy, it will be equals to 10, and that will be uyt plus half of ayt squared. So uy, again, that's u sine theta, and t. Half ay, we have to remember that it's a negative 10. Negative because it's going downwards, and t squared. So we're going to use this equation or this expression of t and make it into this equation so that we can cancel out some of our values here. Okay, after substituting and doing the computation and simplifying everything, we will have this equation where we have a tangent and a secant squared. So now we have reduced it to a trigonometric problem. How we're going to solve this is we're going to use the trigonometric identity secant squared there will be 1 plus tangent squared. This is from the Pythagorean identity. So we're going to use this expression and substitute our secant square. After simplifying everything, you should have a quadratic equation in terms of tangent. And this one you can use the what we call the quadratic formula to solve, right? But if you know how to use your calculator to type it, they'll be even faster. The two solutions you should get tangent is 2.524 or tangent is 0.7691. Solving for theta values, one is 68.4. We'll round it to 1 decimal place is enough. And the other one is 37.6 degrees. Okay, so for this mechanics paper, usually we represent it as degrees unless the question states otherwise, especially for projectile motion. So these are the two values. Yeah, it just clears the wall. Now we have part B. Given that it clears the wall, find the minimum distance from point O where P can land. So again, I'll redraw. Let's say we have U is 24 meters per second. And then it goes, this is the wall maybe. And this is the ground. So we want to find the minimum distance of Sx. Where, I mean, when it lands again, right? After it lands, this the displacement in the y direction will be 0. Okay, so that's the information that we will need to help us to find this one. So obviously, if you think logically about it, if you have two trajectories, let's say a theta which is larger, like that, maybe if you have like that larger value of theta, so logically speaking, it will be closer, or the displacement in the x direction won't be so big compared to the lower value of theta. So, but we need to prove it empirically here, so that we're going to substitute both of the values of theta inside. So first of all, again, we have our requirement or the specification where sy is 0. That is where when it lands on the ground. So we're going to use the kinematic equation again, this one. Since we have the acceleration, for which again the acceleration is downwards in terms of y, so it's a negative 10 meters per second squared. And we also have the initial speed, but what we don't have is the time. We have everything else except the time. So we're going to use yeah, the same equation. Sy is uyt plus half ayt squared. Sy is 0, uy is u sine theta, and half of ay, that is a negative 5t squared. Okay, here we can we can factorize the equation a bit. So either t equals to 0 or t equals to u sine theta over 5. And yeah, using this, we're going to use the other piece of information as x in the x direction. Just now it was the y direction. Now in the x direction, we also have the same equation as x uxt plus half axt squared. But again, in the x direction, we assume there's no air resistance, so this goes to 0. We're left with just this expression. So we can use the information we know, which is ux is u cosine theta, and t is what we have just found, right? This expression here. Obviously, we're not going to take t equals to 0 because that's the instant when it's being thrown. This is t equals to 0, so we're not going to consider that. And we have u sine theta over 5. So again, this is sx. So you get u squared sine cosine 5 over 5. Yeah, so we're gonna try with two values of theta, and technically speaking, this is just a function of theta, right? So I'm gonna take when theta is, what was it already? 68.4 degrees. This value of theta yields 39.4 meters. Now we go for the other value. after comparing these two values, you'll notice quite obviously the minimum distance will be gotten with the larger value of data. Is get yielded by this one, which is 39.4 meters. Okay, so this is the minimum distance. And yeah, I think that's what the question wants, right? Yep, the minimum distance from point O where P can land. So this is both part A and part B of question 2. Okay, thanks for watching.